Hi everyone, and welcome to your quick crash course on logarithms. This is the stuff that you need to know to do the homework, and I know some people were confused on it in class, so I'm going to talk about it now. I'm going to go a little bit quick, but I am going to introduce from the ground up as if you've never seen logarithms before, because some of you haven't. So let's get started. Logarithm, the thing to keep in mind about logarithms is that they are just another way of writing things with exponents. That is the main thing you need to know. It's another way of rewriting things with exponents so that I can put it in the calculator and get out an answer. Kind of like how inverse trig does when we learned that in geometry. We rewrote it so that we could solve for the angle and put it in the calculator. Here we are rewriting so we can solve for an exponent and put it in the calculator. So let's take the numbers 10, 3, and 1,000. There is a mathematical truth that involves these three numbers, which is that if I take 10 and multiply it 3 times in a row, I get 1,000. All right, and there are 3 different ways to write that. Exact same thing. So if I, for example, if I know the 10 and the 3, and I want the calculator to give me out 1,000, the way that we write it is to say that 10 to the 3rd power equals 1,000. And that's a shorthand way of saying that when I multiply 10 together 3 times, I get 1,000. Okay? Now there's another way, There's another way that you should be familiar with that also uses 10, 3, and 1,000. But let's say this time I know the 1,000 and the 3, and I need to get back the 10. Well, the way that I write that and type that in the calculator so I get out 10 is to say the cube root of 1,000 equals 10. And this is saying that the number that I need to multiply together 3 times to get 1,000 is 10. So here the answer was 1,000. Here is the way to write it so that the answer is 10. But there's one more way to write it. I want to find the way to write it so that the answer is 3. So that the answer is the answer to the question, how many times do I need to multiply 10 together in order to get 1,000? And this 3rd way of rewriting it is what a logarithm is. And so the way that we can write this with these 3 numbers is that the log base 10 of 1,000 equals 3. This is the other way of writing it so that now 3 is the answer to my question. So let me break that down a little bit further. And the main thing that you need to remember is that the answer to a logarithm is an exponent. So 3 is the answer to this logarithm question. 3 is the answer over here because 3 is the exponent that we put above 10 so that the answer is 1,000. I have 10, I want to get to 1,000, what exponent do I put there? That's what a logarithm is, and it's rewriting it so that you can figure out what that exponent is. It is meant to solve for when you don't know the exponent. So let me break apart the pieces, and I'm going to try not to get too technical here and just give you the stuff that you need to know. Okay, log base b of a equals x. This is our overall structure. And so you may see these names come up when you learn logarithms. B is the base. b is the base. So it is the number that gets raised to a power. And a is what's called the argument. And you may see this term argument in some other contexts in math. So, but a is the argument. So a is the result that you want to get out when you do the exponential problem. And then remember, this turns into an exponent, because the answer to a logarithm is an exponent. All right, so that's the main thing that you need to know, is that it's another way of writing an exponent function so that you can figure out what the exponent is. So let me get you used to rewriting these with a couple of examples. Let's do one first where we have everything all worked out so that we can interpret what the thing is saying. We are saying the log base 4 of 16 equals 2. And so what that is saying as an exponential expression is that 4 is my base. Remember that the answer is the exponent, so 2 is the exponent. And then 16 is the argument, so it goes on the other side. So what this is saying, the reason a log base 4 of 16 is 2 is because 2 is the exponent we put here, so that when I raise 4 to that power, I get 16. All right, now usually it won't all be worked out for you, so let's say we wanted to evaluate what the log base 3 of 81 was. Now I need to figure out what that number is. Remember, the answer I'm looking for here, this x that I'm looking for an exponent. I'm looking for what number is going to go there. Let me change this problem very quickly. Okay. Log base 3 of 81 equals x. So 3 is the base, so 3 goes down here in the base. The answer over here, my x, is the exponent. 3 to the x equals 81. So that is the question that this is asking. A way that you can manipulate this around is that here's the base. It gets raised to this power, which gives me this. I'll show that move in the next example. But that's asking, what exponent do I need to put here so that the answer is 81? And in this case, the answer is 4. 3 to the 4th power is 81. So that's the exponent I need to put there. All right, last one. Rewriting around again. Remember, 2 is the base, so it goes down here in the base. My 7, the answer over here on the right-hand side, is my exponent, equals x. And so now that I know that that has to be 2 to the 7th, that means that x is 128, because that's 2 to the 7th power. So again, it's just a way of rewriting these things around so that I can figure out what the exponent is. Usually you'll have to do these last two examples where either I want to figure out what the log is, in which case I need to rewrite it with the exponential and figure out what exponent goes there, or down in this bottom one, I just need to figure out what that x was out in front so that I could get rewrite it so that the exponent was up there and I could actually just figure out what 2 to the 7th is. All right, a couple more things you need to know. So that's what a logarithm is. That's like definition. Now let's talk about some of the stuff you saw today in class, which were log and natural log. Log and natural log are the most common logs that we use. This first log is usually called the common log because it's the most common one that we use. So the log base 10 of x is the log of x. 10 is the most common base we want to use. And so usually if it's base 10, we just take the 10 away and just say that it's log of x. And then the other one that you'll see is natural log. ln stands for natural log. And it is the log with a base of e. Log base e of x. And e is just a number. It's a special number that calculus people and engineers like using because it has some nice properties. But it's an irrational number like pi. So when you see e, that is just a number. And it is a number that we like to use for bases and logarithms a lot of the time, so we have a special kind of name for it, the natural log, and we use ln. So when you saw, for example, the natural log of y equals, I think 6.7 was one of the questions that you used, that we talked about today. And the idea there is that my base is e. I know the base is e because it's natural log, so the base has to be e. And then 6.7 is my exponent. And so I take e to the 6.7 and kind of figure out what that answer is. That's what y is. And so we just put it in our calculator to figure it out. These all have buttons in the calculator. Log of x, natural log of x, e and e to a power each have keys in your calculator. If you need help finding where those are, let me know and I can show you. All right, so let me do a couple more examples where we're writing it the other way. Rewrite each as a logarithm. I'm going to go quicker this time. Remember, the exponent is going to go in the answer. 5 is the base, so log base 5 of my answer over here, 125, equals 3. So log base 5 of 125 is asking, what number do I put here so that when I raise it to that power, I get 125, and the answer is 3. Okay, now let's do this with our other logs that we just talked about. 10 to the x equals 157. So let's rewrite this. Log, the base is 10, so I don't even need to write it because if the base is 10, that's implied if I just write log of 157 equals x. And so this way, when I had it written out as an equation, 10 to the x, I had no way to figure out what that was. But now that I can rewrite it, now that I've rewritten it, I can put it in my calculator and find the log button in my calculator and just type log of 157 and know that x is about 2.195. So about 2.2. Now, this last one, e to the x equals 145. So again, I want to know what x is. There's no way to solve that equation without using a logarithm. So we can rewrite this and say that the natural log, because that is log base e, of this number 145 equals x. And so once again, we're wondering what exponent can I write so that when I take e to that power, I get 145. And so I can type in the natural log of 145, and I get 4.976. So 4.98. So about 5. That's the exponent that I would raise e to and get 145. So that can give you kind of the fundamental ideas that you absolutely need to do your homework. And in the next video, in my follow-up video here, if you want to understand some more ideas of the notes, or if you're wanting a crash course review from pre-calc, then I will have that for you in the next video.